This is an exam question about synapses where you have to describe the active potential of a graph. So you have to state what's happening in A, B, C, D, E, and F. So at A, this is resting potential. And it's at minus 65 millivolts. That's where there's 3 Na plus sodium ions moving out and 2 K plus ions moving in to the axon. So the exoplasm outside becomes more positive than the inside because you've got a high concentration of sodium ions on the outside, all right, or in the tissue fluid. At B, voltage gated sodium ion channels are open. I'm sure you're mentioning voltage gated, and that is called depolarization. And that's where sodium ions are moving in to the axon down the concentration gradient. And that happens until point C, which is plus 40 millivolts. So at C, the voltage gated sodium ion channels close, and the K plus voltage gated sodium ion channels open. And that leads to D, which is repolarization. And because the sodium channels are open, K plus moves out of the axon down the concentration gradient. And that continues until point E, which is hyperpolarization. And that's where the charge in the axon becomes more negative, so about minus 70 millivolts, becomes more negative than the resting potential, and that's due to excess potassium ions leaving. At this point, potassium ion voltage gated channels close, and the charge inside the axon returns back to normal at F, which is resting potential. Don't forget, this resting potential is caused by the sodium potassium pump. It's an active process using energy from ATP. Final point that you can mention is that there's a threshold at which point all of the sodium ion channels open if the charge of the axon goes above threshold. Okay, so that's about 16 marking points there that you need to ensure that you're remembering.